All right, I wanted to post a quick video on how to solve a 3x3 system. That's when you have 3 variables and 3 equations, and as long as you have 3 equations, 3 clues, you can solve for those 3 unknowns. So let's get right to it. We're going to use the elimination method here, where we're going to add the different lines together, and you can call them, line 1, line 2, line 3, or equation 1, 2, or 3, but we're going to add them together and try to get things to eliminate. Now, we might need to use a transformation. We might need to multiply one or both, a couple different equations by some different numbers. So let's start to survey this. I'm looking at this, and I see that the y's will add up to 0 right there. So let's eliminate the y's by adding the first 2 equations together. So I'm going to add those first 2 equations together, and I get 2x plus 4z equals 6. I added the first 2 equations together. Now in step 2, you're going to have to follow 2 rules here. We have to use the third equation, and we have to eliminate y like we did on the first time here. All right, so we have to use equation 3, we have to eliminate y. We don't have a choice. So we're going to use this one, and we have to eliminate 2y. Well, how would we eliminate 2y? Well, we'd need a negative 2y. Well, that's easy. We can just double that second equation, right? We can just double the second equation. So let's do that. I'm going to write it off to the side here. I'm going to double this thing. I'm going to multiply by 2. 2x minus 2y plus 6z equals 8. Now, the second equation, I'm not going to change it, or the third equation, I'm not going to change it at all. I'm just rewriting it here so you can see them all nicely lined up. I'm going to add these guys now. So I'm using the third equation, and I see that the y's are going to eliminate. So now I've used all 3 clues. That's important. I get 4x plus 7z equals 11. I'm having troubles with my 7's and z's today. Let me see if I can fix that. There we go. All right, now we're going to pretend like this is an all new problem. Now we have a 2x2. We've got 2 equations, 2 unknowns. Well, we've gotten good at elimination, right? We can multiply by negative 2, that first equation, and we get negative 4x minus 8z, try z there, there we go, equals negative 12. I add those equations together, these guys right here. I'm going to add those equations together now, the red one and the green one, and I get negative z equals negative 1. That means z is 1. That's the hardest thing, is the first variable. That takes the most amount of work, is getting that first variable. So we've got our first answer. Now we can solve for x by going back up here. Solve for x by going back up there. 2 times x plus 4 times 1, because remember z is 1, equals 6. Now 4 times 1 is 4, so I'm going to subtract 4 on both sides. 2x equals 2, so x equals 1 as well. We've got 2 of our answers, x equals 1 and z equals 1. Now how do we get y? We go all the way back to the beginning and use one of those equations. You got to use one of those original equations, because that's where y is, right? X plus y plus z equals 2. I'm going to go ahead and plug in my 1 and my 1 for x and z. 2 plus y equals 2. Y equals, what does it equal? Is it 4? Well, let's show work and see. What if we minus 2 on both sides? 2 minus 2 is 0. Remember, 0 is a number. You can get 0 for an answer. So x equals 1, y equals 0, z equals 1. If you want, you can even write it as an ordered triplet, I guess you'd call it. 1, 0, 1. I'm fine if you just highlight the 3 different answers as well on in this particular section. Okay, hopefully you found this useful. Now you know how to solve a 3x3 system by combining the different lines, and it's called linear combination. Is a fancy way to describe this particular method. Okay, good luck on your assignment.